You've probably used the Pythagoras equation before in one of your other math classes, so this might be a bit of review for you. The first thing we have to remember is that right triangles have a 90-degree angle, and the reason this is really important is that Pythagoras only works with right triangles. So before we get right to the equation, let's talk about how we label right triangles. So here we have a right triangle pictured, and we're going to label the sides A, B, and C. So A, I'll make the shortest side, B, I'll make the next shortest side, and C, I'm going to make the longest side. The longest side is called the hypotenuse. We often call the shorter sides legs. And so those are the three sides we need, 2 legs and 1 hypotenuse. So now we can get to the Pythagoras theorem, or Pythagorean theorem. So that says that a squared plus b squared is equal to c squared for any right triangle. That has to be true. So in this equation, it doesn't actually matter which leg is A and which is B. They're both totally okay to be one or the other, but we have to make sure that C is the longest side, that hypotenuse. One of the things Pythagoras will let us do is test whether or not a triangle is right. That is, whether or not it has a 90-degree angle. So let's see how we can do this in an example. So the first thing we have to do is label the 3 sides of our triangle A, B, and C. Again, the only one that really matters is that C be the longest side. So since 5 centimeters is the longest side in that triangle, I have to make that C. Now to make the other two A or B, I usually just make the shorter side A and the second shortest side B. But again, it doesn't actually matter. You should get the same result either way. So now what we're going to do is we're going to test to see if these 3 sides fit the Pythagorean theorem. So we're going to fill in A, B, and C into our equation. So A is 3 centimeters long, so that's 3 squared. B is 4 centimeters long, so that's 4 squared. And C is 5 centimeters long, so that's 5 squared. Now I'm going to square each of those numbers. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. For small numbers, you might have those memorized, but you can always go to your calculator and type in 3 squared or 3 times 3 to get those squares if you don't remember them. So now we have to ask ourselves, does 9 plus 16 equal 25? And it does. So if you get a squared plus b squared giving you 25, and c squared giving you 25, then basically what we've just done is proven that this triangle is a right triangle. If each of those sides obeys the Pythagoras equation together, then it must be a right triangle, and we can go ahead and put a little right angle symbol into the corner of that triangle. Let's do one more example. So we have a triangle with the 3 sides given to us. It's sort of on its side, but it doesn't matter. We can go ahead and start labeling it, and we just have to again make sure that C is the longest side of those 3, so I'll make that on the 14-meter side, and then A and B can be those other 2 sides. So a squared plus b squared equals c squared for a right triangle. Let's see if these 3 sides fit that equation. So a we made 7, b is 12, and c is 14. And then we'll have each of those 3 things squared. So go ahead and square those 3 numbers. Again, you can use your calculator if you don't have those memorized. I don't know 14 squared. But when I check in my calculator, I get 196. And so now, again, we're going to test what's 49 plus 144. Well, using my calculator, I find that it's actually equal to 193, which is not equal to 196. That means this triangle is not a right triangle.